Hello everybody, I'm your host Hal Curtis and I'd like to welcome you to The Space Industry by satsearch, where we share stories about the companies taking us into orbit. In this podcast, we delve into the opinions and expertise of the people behind the commercial space organisations of today who could become the household names of tomorrow. Before we get started with the episode, remember you can find out more information about the suppliers, products and innovations that are mentioned in this discussion on the global marketplace for space at satsearch.com. Hello and welcome to the episode. Today I'm joined by Khaki Rodway and Patrick Van Put from Bradford Space. Bradford Space is a widely experienced US-owned business with operations in New York, the Netherlands, Sweden, Luxembourg and Seattle. The business develops propulsion systems, avionics, attitude and orbit control technology, microgravity workspaces and provides logistics services for missions beyond low Earth orbit. Bradford Space is also a satsearch member. Khaki is Director of Business Development at the company, and Patrick is Managing Director of European Operations. Today we're going to discuss green propulsion in small satellites. So firstly, hello Khaki and Patrick, welcome to the Space Industry Podcast, and is there anything you'd like to add to that introduction?
No, I think you've done pretty well. Thank you for organizing this and happy to chime into your questions today.
Yeah, likewise. Thank you very much.
Great, fantastic. Well, let's dive into the topic. So today we're going to be covering a number of areas related to recent developments in high performance green propulsion, HPGP. Now, this has been a core focus of Bradford for a number of years, so I wondered if you could provide a quick overview of the evolution of HPGP and its maturity towards a TRL-9 technology, as well as maybe how it's utilized in the industry by satellite manufacturers.
Yeah, thank you for that question. Just a brief history. Bradford ECAP's HPGP systems were developed in Sweden by the Swedish Space Corporation as a low toxicity propulsion solution using ADN. So in 2010, the first 1 Newton thruster was launched on the Prisma satellite. So that was operated until 2015. And in 2017, SSC sold ECAPs to Bradford Engineering, which is now the U.S. part of the U.S. Owned company of AIAC. And today, Patrick can correct me, but there are over 90 1 Newton thrusters operating in orbit on 23 spacecraft.
Absolutely correct.
Yeah, brief history.
Yeah, and I think part of the question, if I may chime in, is also on the technical evolution of how do you get to TRL-9, right? So this is the typical chicken and egg scenario. So of course there was always a desire to go green propellants, and I think this is already existing for many years. When ECAP started 20 years ago, in order to get to the market and to offer something beyond what was utilized and used at that point in time, which is mostly hydrogen, we needed to come up with some key differentiators. And in order to come up with key differentiators and to get flight opportunities, you also need to have drop-in replacement. So that was actually the original plan, is to define unique selling propositions for a new technology, which is better, faster, cheaper, better, if you would put it the American way. But also, how do you fly these things on existing systems? So originally the focus was to define it to the optimum performance, get the best ISP of the market, get it able to run it as hydrogen thrusters, but also to be able to drop in as hydrogen thruster. In other words, getting it into a traditional hydrogen system and run it the way hydrogen thrusters would be run. So, I mean, different technology, it requires some different ways of operation, which you'll learn later in the question scenario, I would think so. But so we defined operational box and scenarios in order to be able to operate in an environment and to be able also to show the benefits of this HPGP technology. And that was the cool thing. We got an opportunity supported by the Swedish authorities and government is to fly a one-to-one comparative propulsion system on the Prisma satellite, as Khaki just mentioned, which was a unique opportunity to fly a full hydrogen system and a full HPGP system and to do an in-orbit one-to-one comparison and operation scenario and show the true benefits of this technology. So that's how we got to TRL-9, and I think that has been the case for many years, the last couple of decades, and things are changing rapidly now in the new space era where flying things and getting to TRL-9 is much easier than it was 20 years ago. So 20 years ago, we were fully reliant on the government to support us to fly the first time, gain confidence, get this TRL9 status. And since then, I can tell you that since Prisma, we have done many evolutions on the 1 Newton thruster in order to make it better, in order to get better supply chain, to industrialize it, and also to make it more reliable and robust for longer duration, also deep space missions. So beyond the original expectations of a 1 Newton thruster. So many evolutions there.
Oh, that's fascinating. It's quite a long journey, and very interesting that you were able to do that one-to-one comparison early on. I think that's something quite different in the industry, as you discuss the opportunities for in-orbit demonstration today are a lot greater than they were at the time. So,
yeah, I think that was the coolest asset we were offered at that time, because it removes all the ambiguity between the one or the other performance, and you can argue on several things, and people may criticize certain things. And if you now do it on the same spacecraft and do two independent systems, run them, and show the benefits, that was really a very unique opportunity.
Absolutely, and on that, there are several different solutions, for propulsion systems, depending on the size of the spacecraft that's in the mission. So for what range of satellite sizes and mission profiles do you think HPGP solutions are an ideal fit?
Okay, first of all, I think like anything else, HPGP monopropellant solutions are not a one solution fits all kind of applications. If you see the size of spacecraft, we are usually picturing anywhere between 50 and 400 kilogram platforms, typical ESPA Grande type of rideshare opportunities, where the advantage of 20% more storage capability of this propellant gives 20% more performance in the traditional volume. That pays off in rideshare opportunities. So that's why I think for a long time and still in the future, we position ourselves in this 50 to 400 kilogram range. But again, nothing is mutually exclusive, so we can go bigger. We can go on space tugs in the future and serve other applications. But if you really look at most value for money, I think that's the sweet spot in the market.
Excellent. That's interesting. Now, the propulsion fuel itself, HPGP itself, has various advantages in terms of storage, handling, shipping, etc., because of the very nature of the compounds. Can you sort of put these into perspective compared with the more traditional propulsion solutions that have been popular, such as hydrazine?
Sure. I mean, the biggest element in non-toxic propellant technologies, as we are discussing here today, is indeed in storage, handling, shipping. So the whole idea is to make sure that the total cost of ownership of a given system using this monopropellant technology is actually cheaper than the competitive hydrogen product. I mean, that's the focus of a lot of spacecraft manufacturers, and that's what it really is all about. I mean, if you then on top are able to offer more capabilities and more performance for the same volume, then we are talking business, obviously. If specifically you talk about storage, handling, and shipping, the ultimate goal we'd like to achieve with this technology is to be able to fuel at the factory, which means you build a spacecraft, or we build a drop-in propulsion system. We fuel it in our facilities, we test it all out, and we ship it on a commercial aircraft to the end user, which integrates it on the spacecraft, and then the spacecraft moves on and effectively be launched. So that's the dream scenario. The current situation is that we are able to ship the propellant and the propellant on a commercial aircraft under a DOT 1.4S license, which means just barrels of propellant on commercial aircraft. As we fly overseas, we will be joined by a number of cans of this HPGP technology. It can be stored in non-controlled environment. It's safe for human health. So in terms of handling, storing, and dealing with it, you typically don't need the escape suits and all the precautions you would require for hydrazine handling. So as a matter of fact, you ship it on a commercial aircraft. It can be just truck loaded and shipped to the launch site. Without too many precautions, we can just fuel it into spacecraft with not much protection clothing and things around it. We can check it all out, and it can be launched. So inherently, it is very safe, And with all the things I just mentioned, in the end of the day, the total cost of ownership and the handling fees are significantly lower than hydrogen. And if you would wish so, you could even drink the propellant. If you pour it with a lot of water afterwards, you won't die from it. So it's a much safer solution.
Interesting. It conjures up images of people drinking the biofuel for their cars in different countries around the world. So,
yeah, indeed, it won't kill you, but it won't make you stronger. It's still a high energetic solution, but in this case, if you dilute it in a lot of water, so if you drink a lot of water afterwards, it will not result in human injury or death.
Yeah, well, I think that hammers home the safety point, that fact. So that's really interesting. Now, apart from these advantages, I think you've touched on most of the things there, but are there any other significant sort of aspects of the delivery, the quality, reliability that helps HPGP to stand out?
Yeah, definitely. And it's important for listeners to know that we've never had a failure in orbit. So that is one very strong distinction that we have. But there are benefits at the spacecraft level with the integration and lower overall propulsion system lifecycle costs as well. So there's a lot of advantages. You can certainly find these on our website, but just to go through a few, increased performance. As I said, life cycle cost, extended missions are definitely advantages and capabilities that HPGP has. Increased rideshare opportunities. So now as you have a lot of these launch companies, launch vehicles like SpaceX, and then you have now a lot of these smaller launch vehicles coming online. There's going to be a lot more rideshare opportunities for spacecraft. And so, as Patrick just mentioned and outlined, because of the safety of HPGP, it makes it a whole lot easier to do this as a rideshare opportunity and use HPGP. As I said, I mean, that's some of the new opportunities. You know, we also in our family of HPGP systems, we have thrusters that can fit on CubeSats. So on the new opportunities level, say a university or other small company who is developing small CubeSats can now have propulsion and be able to maneuver and go where they want. So the other part of this is, besides being environmentally safe, it enables a more profitable business for the customers who are using this. And, because of lower costs and higher performance, you can get more, so we say bang for the buck on your spacecraft. And, so it, also reduces the environmental impact. So these are some very distinct advantages that we have over, say, something like hydrazine. And over EP as well, because of the higher performance that you can get on HPGP.
Great. It seems like a lot of this is enabling space missions and teams to have more opportunities and be more versatile, whether that's because they can fuel at the factory or because the fact that it's easier to handle the propulsion, the propellant, and then they can do more in space, as you mentioned, potentially. So that's really interesting, and I think that's a message alongside the total lower cost of ownership and high reliability. I think that's something that's important for teams, and obviously the factors that play into the design of satellites are not just dependent on the goal of the mission themselves. There are also broader regulations and compliance that the teams have to adhere to, and in that, I think a lot of people are increasingly worried about the environment in low Earth orbit and other orbits potentially becoming more crowded with the constellations out there. And so, do you see the sort of design choices for small satellites being influenced by the threat of space debris and the overall space situational awareness requirements in the coming years? And to follow up, do you see HPGP playing a role in this, in mitigating these potential impacts?
Yes, I think absolutely. I mean, if you look at, well, design choices, space debris rapidly is becoming a major concern for all of us, and I think this is on the good and the bad, initiated by SpaceX with their Starlink constellation. Like every month, we see 52, 70, 64 spacecraft going up, and multiple hundreds and even thousands of these small spacecraft are up there. I think the lack we are facing today is that we are truly lacking regulatory requirements for space debris and for deorbiting. Although I think SpaceX, as an example, is also serious about deorbiting possibilities, that if there's an issue with payload and spacecraft, they would be able to deorbit it and replace it with some new satellites. So I think that's a good scenario. Some companies made space debris removal a living, like Astroscale, a venture from Japan who raised a lot of funding, and which we happily joined in their first undertaking on LSAD to do the first in-orbit demonstration of a debris removal vehicle. And I think HPGP plays a role in all these things, including space situational awareness, by being a chemical propulsion system, be able to act fast, be cheap. Remember that I said earlier, fueled at the factory. So having spacecraft ready, which can be launched and fueled already when needed, and being part of a replacement and operation plan for constellations like Kuiper or Starlink, by effectively just assuming or taking into account a number of failures in orbit and having a number of ECAPS HPGP propelled satellites around for removing failed spacecraft which do not have the opportunity to deorbit themselves. I think this is rapidly becoming a business in itself. And well, as I earlier noted, SpaceX is helping a lot by getting hundreds and thousands of spacecraft in orbit for that. So, and yeah, again, we are happy to have joined Astroscale, but I think there's a lot more opportunity and a lot more future needs for this. And chemical propulsion will play a major role in that. We are convinced of that.
Yeah, and let me just add, I mean, as Patrick has mentioned, HPGP is already playing a role in this mitigation, you know, being the Astroscale propulsion system, for example. And so we foresee further development, because here in the U.S., one of the things that was proposed a couple years ago, actually, it was a requirement that came out by the U.S. government that said any new satellites had to have maneuverability. So be able to deorbit, be able to avoid collisions. There was a report that came out. There was a requirement that was produced, and then quickly retracted because the industry had not made provisions for that. So it was kind of a surprise here, but that will be forthcoming again, because as you said, as we start to see a lot of overcrowding in space and in the Earth orbit, there will be policy requirements. In fact, I wouldn't be surprised if we don't see that by the end of this year, at least coming from the U.S. side, and then probably going out to the rest of the world following that. So it's going to happen. It's just a matter of when, and we're ready. As we said, we're already playing a role. So we expect to play a larger role.
Yeah. I don't think many people would be surprised if such regulation came into force, and it would be interesting to see how the market adapts. I mean, again, it's back to versatility, right? So we'll see. And okay, so to take things further away from the Earth, my next question would be, how relevant do you think HPGP propulsion systems are in interplanetary or deep space contexts?
Khaki, is this something you would make a first comment on?
Oh, sure. Okay. So Bradford Space is developing a transport vehicle. We call it Square Rocket. And again, you can find this, you can find the payload planner's guide on our website. But this is a new rideshare compatible spacecraft for space to space transport. So getting small satellites beyond LEO is the goal for this. And on square rocket, we are using the 1 Newton and the 22 Newton HPGP. So it's essentially a third stage that will get small sats from LEO to HEO, GEO, cislunar orbits. Its propulsion system is a new propulsion system in development. The system as a whole, anyway. And Patrick, you can explain on this a little further. But it's going to be a pump-fed HPGP system, which is in development right now.
Yes, exactly. And this is in our master business plan. We want to offer to go with based on HPGP technology anywhere beyond LEO. So interplanetary deep space is the mission concept. It will include, as we discussed in the previous round, space debris removal is an option. Space situational awareness is an option. Cislunar orbits are options. And if you want to do these things and want to break away from Earth and go interplanetary, you need almost inevitably need a chemical propulsion stage. So we are, with our business plan, the Square Rocket, we are looking at more propellant utilization in a given volume by square tanks. That's why Square Rocket. As Khaki noted, we will define a pump-fed system in order to have better use of propellant, and of course it's fully based on HPGP technology. So inevitably, the whole business plan is based on this technology. We call it, as we are the number one true green non-toxic propulsion technology around here with a TRL9 status, as we just started the discussion of this podcast. We believe we have the golden egg in technology and are a decade in advance of the competition on these technologies. And again, nothing is mutually exclusive. Electric propulsion is around, but there will be a lot of opportunities utilizing chemical propulsion technologies. And I think the performance characteristics of our HPGP technology stand very well to serve a large portion of the market.
Oh, interesting. That's great. And I guess a follow-up question then that also relates to the versatility and the change in applications of the same core technology. We know that there are various projects underway discussing the refueling of spacecraft in GEO primarily. Do you foresee that there will be cases where this could occur in LEO in certain applications or services?
Absolutely. I mean, if you see companies in the US, startups like Orbit Fab are already thinking about LEO kind of refueling systems. They are obviously considering HPGP as an option. And the more spacecraft it would utilize and use our technology, the more refueling would be desirable. And indeed, one could think about getting refueling stations and having this kind of propellant in orbit. You are being dropped off low Earth orbit. You make a few maneuvers and get to a more convenient orbit, let's say, in which you consumed a vast majority of the propellant. You can refuel and actually go further in space. Or if you want to come back to Earth, you can consider refueling in LEO to come back to Earth as well. So there's a lot of opportunities created. And I think we strongly believe, although it's a bit early, maybe early adoption, but LEO refueling options will also play a major role in the future business utilization of any space exploration.
Yeah, and let me just add, if someone out there listening to this is interested in doing this and using LMP and refueling, please contact us. Let us know, because we're available to help develop this system, put this together. Obviously, we would have a stake in this, because using our propellant, using propulsion systems. So yeah, we would be very, very interested in helping them develop this and work with them to produce a really good system.
Interesting. It's an interesting application area, and I mean, one of several that you've mentioned that such propulsion technologies unlock for the industry. So my final question builds on that. I was going to ask, apart from some of the innovations that we've discussed, where do you see the market heading in the next 5 years? You know, what areas are you most excited by, or what gives you pause to reflect on certain parts of the industry?
Yeah, that's the usual very interesting question. I think when we extrapolate where the market is heading towards today, I think it's clear that the more capable, smaller spacecraft is a main focus, and a lot of developments are ongoing. Lower cost rideshare launch opportunities are inevitably a key factor in that. I think this is something where cheap launch opportunities is the SpaceX Starship. If once this would be in operation, there would be such a tremendous amount of payload which can be brought into orbit. I think this will again change the paradigm shift of launching satellites into orbit. Yes, and I mean there is any spacecraft which is defined, whether small or big, will need propulsion in the end of the day. So the larger the market grows, the more opportunities non-toxic propulsion technologies will play an effect in it. And that's the current market evolution. The interesting thing is that the market is defined by just a number of players like SpaceX and soon others will join, I'm sure, but they are defining a way in the traditional telecommunication, Earth observation, that kind of thing. So the traditional market, where we are after is in 5 years is to create our own market. And that's why our Square Rocket solutions and business plan we looked at is to have services of any kind to go anywhere from LEO. So undefined for the moment, but with our Square Rocket, we try to define our own market and to define new opportunities together with partners and customers and people who want services. So we are listening very carefully to the market. And again, we are after not just to create a Me Too spacecraft in an evolving market, but we want to create a completely new area of space travel. And as we call in our business plan nicely, capturing the solar system with our Square Rocket. And it's all based on HPGP technology, and is the subject of this discussion.
Fantastic. Well, best of luck with all of these plans and the development of this new market. I think you've got a great heritage at Bradford over the years, and so it's been really interesting to learn from you both about this area of the technology. So thank you very much, both of you, for being a guest on today's podcast. We really appreciate you sharing all the insights with the community.
Okay, you're very welcome, and hope this podcast is listened to by many. And if people wanna reach out to us, feel free to jump on the website bradfordspace.com and drop us a note, and we're happy to assist you and help you to go anywhere you want to go from LEO.
Thanks, guys. That's great. And to all our listeners out there, please remember you can find out more information about Bradford Space on satsearch.com. On the platform, you can also make requests for quotes, more information about products, documentation, introductions to businesses, and whatever else you might need for your trade study or procurement purposes. Thank you for listening to this episode of The Space Industry by SatSearch. I hope you enjoyed today's story about one of the companies taking us into orbit. We'll be back soon with more in-depth, behind-the-scenes insights from private space businesses. In the meantime, you can go to satsearch.com for more information on the space industry today, or find us on social media if you have any questions or comments. To stay up to date, please subscribe to our weekly newsletter, and you can also get each podcast on demand on iTunes, Spotify, the Google Play Store, or whichever podcast service you typically use.